Our first example is using processing to update our Arduino, and this makes a notification LED so we don't have to be looking at the screen all the time. And just for fun, I've made it so it tells me if I should wear a hat or not. So I'm calling it the toque notifier, and I can have it run and tell me if it's cold outside and if I should wear a hat. As you can see on screen, it gives us the date, it gives us the current time in Eastern Standard Time, just to show that we can get the accurate up-to-date time from a different time zone. And I'm showing the different ports that are plugged in just because on my computer the Bluetooth is the one that always takes port 0 for some reason, and that means that I need processing to talk to port 1, which is my Arduino Uno. Let's have a look at the code. We'll look at the processing side first, and this sketch has to use some libraries, but the ones at the top here are just in case you want to do any date math, because the dates you get back from the service are strings and you'll need to manipulate them if you want to do that. I'm not doing, I'm just using the temperature that we get from the weather. So we're using serial to communicate with the Uno, and we have to set up a font because I'm outputting to the screen, and we set up some JSON objects. So if you recall from before, JSON is a textual data format. It's formatted in a certain way so it's both human and machine readable, and the data we get back from the weather service looks like this. And the really vital part that we're looking for is we're getting the temperature, and we're getting the temperature in Kelvin, which we'll get to in a second. So you can see this is Calgary. You can choose your own, just have to change the city and the country code. So we set up some JSON objects ready to get some JSON down. We set up the port so we can see the Uno and we can talk to it. And on startup we actually output the list of ports. On my machine I've got about 5 or 6, and the first 2 are the most important because that's usually the Bluetooth and the Uno, but on your machine you might want to have a look at that list and see which your Uno is. Usually the last plugged in will be at the top of the list. Processing loops round and draws on screen because it's meant for things like graphics and animation. So instead of loop they use draw. We set the background color, we set the text color to white, and then first of all we get the world clock, and we ask for Eastern Standard Time, and we want the time now, and we want it in JSON. And this is a way of getting the information that we want out of that because it's delimited. It's separated by a T. So if we get the date first and then we get the time. And again, to get the time we actually split it with a hyphen just so that we don't get the bits that we don't need. And then we display the ports 0 and 1 from that list, and these are just the coordinates on screen that we're writing them to the display. And then this is the weather, and that's that link that I said before. First of all we get the whole weather object, which is all of this, but then we don't want all of it, we want just the bit we really need. So I have to do another JSON object which is just the main, and I'll show you that. So there's a service that I use called Json Parser online.fr. It's a French site, and it allows you to take a big mess of stuff like this, paste it in, and actually find out how it's all organized. And this is the bit we want, main. So you can see main provides us the temperature. So going back, we get main, and then from this JSON C we actually get the integer temp, which is the temperature. And then to get Celsius from the Kelvin, we have to take away 273.15 for some reason. And so we get current C is current C minus 273, and this is just an easier way of saying the same thing. So you could do current C equals current C minus 273.15, but I'd just do minus equals. So we've seen plus equals before. This is the reverse, essentially. Then we output that to the console just for debugging purposes, and if the serial monitor is available, we check to see if it sent a string with a carriage return, and as before we're just sending ready. And then I say, is it cold enough that I need to wear a woolly hat? If the current Celsius is less than 5, then I output wear a hat and the temperature, and I send 255, which turns the LED full on. If not, I just put the temperature and I turn the LED off. Remember the function in the Arduino where we send a prompt and wait for some information back? That's all we're using again. So we send the monitor input ready, and we get back brightness, and we set that brightness to the LED. So if we get 255, it'll be full on. If we get 0, it'll turn it off. And it just takes the string that we get back from the serial monitor and we turn it into an integer. As you can see, currently it's cold enough that we need to wear a hat. Blynk is an app and a set of services that allow you to control your devices from the internet and also send from your devices to the internet. As you can see, you can create a very simple user interface, and you can share your apps. You can even put them on the App Store. And to create your user interface, you've got all these different widgets that allow you to put in sliders and gauges and displays and all kinds of things. And you can notify email, Twitter, all kinds of things. In my case, I'm simply using a button and a LED, and when I press the button, it updates my Arduino to tell it to turn the LED on, and my Arduino tells the app to switch the virtual LED on. So if I hit play there, it starts the app, and we can see in our serial monitor that the Arduino is connecting and it's getting the IP address, and once it's connected we'll be able to control our LED. So let's try that again. Now I've got the correct authorization token out of my email, which should be able to connect okay. So it's got an IP address, it's connecting. Now it's ready. We can turn the LED on, turn the LED off. The code we actually get straight from Blynk, and you can see they've got a ton of different devices that you can use. Obviously I'm using an Arduino Uno, and I'm using the ENC28J60, and it gives you code that you can use straight away. Now Blynk is just a blink sketch, and it blinks the LED on and off, the virtual LED on and off. But you can read and write to virtual pins that will control your user interface on your app, or you can use buttons, you can push information up and you can push information down, all of that kind of stuff. I've modified my sketch so that the button will control my onboard LED, and then I send information back up to control the virtual LED on the user interface. So I've got a physical pin in digital pin 3. I've got serial so that it outputs all of this stuff into the serial monitor using the UIP Ethernet library, the Blinks library for the Ethernet. Put in your authorization key here, the API key. It's like a password, don't share it with anybody. And I've got an LED widget in my app, and then this code is fired every time they want to change one of the virtual widgets. So that's how they let us know that pin value has changed. So when the button changes, the pin value will be either off or it'll be on. And so we can set our physical LED to high and our virtual LED to high. And in the setup, you have to tell the Blynk that you want to begin and what your authorization key is. And then in the loop, you have to make sure that it runs every time so that it keeps up to date and it's constantly pinging the service. It goes beyond just using their code. Once you've got it set up so you can do a notification LED, you can be notified about all kinds of things. For example, I've set it up on IFTTT so that if anybody mentions maker hacks, I get a LED light up. And the way it does that is with a web request, and it's one of the services that is built into IFTTT in that they can do a web request, i.e. call a URL. So they just ping a URL with a value if you want, and whatever is on the other end of that will respond appropriately. And with Blynk, we can do a HTTP request as well. So IFTTT calls a web page which sends the information to Blynk, which tells Blynk to turn my button on, which makes my LED light up.